Hey there. Welcome, friends who are live and also friends from the future. Thank you for joining me. I'm Penguin on the internet, Jeremy Tanner in real life, for Metal Monday. Am I aware that it is not actually Monday? Yes, but time zones are hard, really hard sometimes. Here to help us work through some of that and talk some of the most recent ARM news, my friend Ed Vielmetti, who I will have join us now. Perfect.
Hey, Jeremy.
Hey there. Happy Tuesday.
Happy Tuesday, or probably Monday in some weird offset time zone. So
yes. The with the speed at which time is going, it's still like it's the 30th hour of Monday
of a really long Monday. Yeah. Good to see you. Glad to be here.
You also coming to us from Michigan.
Coming to us from Ann Arbor, Michigan. Yes.
In Austin, Texas, myself, and so I have not had the opportunity to see so much of Ed in the real life, but virtually I get the opportunity now and then. You are primarily focused on ARM things, yes?
I'm primarily focused on open source things these days, where the ARM stuff is a big chunk of that, and the Kubernetes and cloud native world is the other big chunk of that. So those worlds overlap in a lot of places, and makes it a lot of fun because I did a couple years worth of ARM work here at Packet and now Equinix Metal, running the Works on ARM program, where we provide infrastructure to open source projects for their builds and for their CI and for their porting efforts, and pretty much steeped in that world. It's been a lot of fun.
Yeah. Tell me more about Works on ARM. What sort of projects and providing what sort of help and equipment?
We have about 125 machines reserved for the project. A mix of our first generation Cavium ThunderX hardware and second generation Ampere computing eMag hardware. About equal 50-50 split more or less right now. The projects run the gamut, but generally speaking, the first ones that came on board were people with programming languages or software libraries that go along with them. We have a number of languages that you've heard of and maybe a few that you haven't, Haskell and Swift. We have Go and Node.js and some folks from the Rust community. So just a broad range of languages and some of the libraries that go with them. LLVM is another one. We've got a couple LLVM projects going. And then operating systems is probably the next one by volume. Alpine Linux is one of the favorites, an operating system we use a lot at Equinix Metal. Little teeny tiny memory resident system with a great package manager and a tremendous community compared to the size of the binaries, which is a really good fit. So that's been good. The Debian project uses our equipment. We're on good speaking terms with pretty much everyone out there. So. And then the other big bulk of the effort is on CI/CD systems. So looking at people who need infrastructure, not to port their code, not to build their packages, all of them, but to focus on one project and build it continuously as people try to update it. So we've spent a lot of time working with build systems, Make, right? There's nothing more fun than running Make -J96, I have to tell you. Get all 96 of the relatively slow cores of a ThunderX going, and you can have a lot of fun, build your projects really quickly, even though this computer's not, the individual cores sometimes are not that fast, but in aggregate they do really well. But that's hardware from 2016. Things have really come a long ways in 4 years, and we're looking forward to the next generation of Ampere hardware, the Ampere Ultra, which is 80 core, 80 fast cores, and then a dual socket 160 fast cores, which I'm very much looking forward to getting my hands on directly.
So that's like a passenger car or station wagon full of your full of Raspberry Pis or something like that, but in a much tighter, more data center friendly.
Yeah, never underestimate the computing power of a station wagon full of Raspberry Pis. Yeah.
I'm imagining the power setup and the rest of it.
Yeah, so it's been a lot of fun. I started working on that. My good friend Dieter Reuter sent me a Twitter DM back in 2016 and said, "Hey, Ed, you need to check out these Packet guys. They have this crazy computer that has 96 cores in it." I said, "Dieter, sign me up. I'll be a beta tester. Just introduce me to them." So I met with Jacob Smith and got a chance to meet him in person later that year, and then slowly rearranged my schedule so I could start working for Packet part-time, and then got hired in 2017, and it's been quite a ride. As you know, and as our listeners may know, we got acquired by Equinix this spring and got a big boost of energy from that global infrastructure organization. And then Packet got rebranded as Equinix Metal, so we have to get all new business cards, hoping for shiny business cards this time. And
yeah, a shiny coat of paint on the artist formerly known as Packet. And so, but the exciting part of that is the resources of the larger company and being able to be in so many more places. And so having north of, I think it's 220 different locations that hardware can be, and starting to grow into those with with Equinix Metal machines, and by extension, some of those ARM machines that'll be available via Equinix Metal.
Yeah, the ARM server world, has gone through a bunch of, can I say turmoil on this word? I think turmoil would be appropriate.
Yeah, there's no buzzers.
We had some vendors decide not to go to market with their products, which was not a setback, but just a detour along the way. One of the really interesting things about the KubeCon that just happened last week was the whole notion of the new Apple MacBook and Mac Mini running on Apple Silicon, which is an ARM-powered chip there, and people, and also along with that, Apple making a big bet on Kubernetes, so much to the point where they're hiring a bunch of talent, and I heard the word AppleNetties a couple times as a like a way of describing what was going on. A lot of the reason that we have done Works on ARM as a project is to give people access to the infrastructure that they need to really.
Still with me, Ed? Hold for one moment. We're going to see if Ed is frozen or can return.
I think I'm back.
Yeah.
Gonna put up a test pattern.
I was gonna flip back to that ARM.
I can see myself. I can hear you, but I can't see you yet.
Okay.
We'll fix it in post-production.
Sounds good. Or we'll do it live.
What is going on here?
Yeah. So where were you at? You were.
I don't know what's being recorded right now, so I'm just going to be confident that whatever it is, it'll work out.
Yeah, I think we're in good shape.
Now I can hear a little bit of you, Jeremy, but there was just one burst of noise.
Okay.
Okay, what do I need to do test what's going on.
Have comments from our Twitch friends.
A
request for a funny joke.
This.
Says requesting a funny joke and you'll follow us. Perfect. Funny joke. Why don't? No, that one's not that funny. What have we got? Here we go. Why do chicken coops have 2 doors? Because if they had 4, they'd be chicken sedans. I thought it was a good one. Back. Perfect.
Back. I have 3 letters to share with you. VPN.
Oh no.
Yes. So VPN disabled and we're fine.
I thought the letters were going to be DNS because it's
always
DNS. In the kitchen with the candlestick or the unterminated RJ45 or whatever.
So where were we? We were somewhere lost in the midst of Ethernet.
You had just said I think Applenettes, and that was on the Kubernetes front interesting. But also I was going to ask if you thought that Apple releasing Apple Silicon, having that many more consumer machines out there was going to be a boon for that ARM ecosystem, and so trying to get
just a transformational moment. You know, when you get a consumer product out there with lots of people trying things out, and Apple's, Apple is famous for their attention to detail, like their butterfly keyboards not working, like their power cords on old Macs always fraying apart. I tell people Steve would have never let that happen, but they have spent a lot of time and a lot of energy on this new chip, and also on the whole software stack. And I have some idea of the scope of the problem. You have to get an entire world full of people who've been busy writing software for some other chip to pause for a moment and consider their choices and support new hardware. This doesn't happen very often, this sort of big change from one architecture to another. I remember back when I had more hair, the Intel PCs were the hot new thing, and everyone was dismissing them as toys. But indeed, that SPARC station didn't have as long a life as it might have. That DEC Alpha didn't keep up with things. There was just like a bunch of architectures. It used to be that every time you bought the hot new computer, you had to port all your software anyway, because not only was the chip different, but the operating system was different. We've mostly homogenized on one or another flavor of either Linux or BSD these days. But what we haven't, and for the longest time, we homogenized on x86 processors, whether they be from Intel or AMD or a couple of other people who tried. But that's really has been very much of a monoculture, and to a certain extent, people have forgotten how to write portable software. Right?
Yeah, I remember that last cutover from PowerPC over to Intel, which must have been 2006-ish, I guess. And getting a shiny new MacBook and thinking the name was stupid, but eventually it doesn't grow on you. But like for all time, like Power, a Power Mac is still way cooler. A Power Book is still way cooler.
Exactly.
Can't beat
that.
But yeah, if it's no longer running on PowerPC, you can call them Mac things, and so the name stays when switching over to ARM. And I guess it'll run in parallel because the Intel machines will be supported for a long time, supported for years and years. but the excitement, yeah, definitely comes from having the ARM processors in that many more hands, and having reasons to reasons for all of the software that needs to be supported there to catch up. I've seen internally a lot of excitement about people who are either who have pre-ordered and are just receiving them. And on Twitter, you can follow the threads. I'll add some of them into the show notes. Folks who are sort of going out there and forging the path and telling us what doesn't work yet and what's not quite ready to come to work with every day.
It's fantastic to me as a person who does this all the time to see things that don't work. Like, I love bugs. I love porting problems. I love things that, and because sometimes the fix is so small. Oh, we need to add one more entry to a case statement, and then it'll work. Hooray, right? An hour or an afternoon's worth of work, and suddenly you've opened up a new horizon. One of the things that people have been having awareness that not everything is going to work day one is, of all things, Fortran. You wouldn't think that Fortran would be a key component, but if you look at scientific computing software or numerical methods or big data being the modern way of describing that, you're writing code in Python or you're writing code in R, which are both relatively modern languages. Those call into libraries with code that's been tested for 50 years, 60 years? Code that has hundreds of thousands of cases in the test suite. Code that's written in Fortran. Linear algebra systems, other sorts of things that are the sort of fundamental building blocks for stuff. I was reading one of the accounts of porting the R language to Apple Silicon, and it turns out, without going too deep into the numerical weeds, if something is not a number, there's a special coding for not a number, and it's a infinity or minus infinity or not a number, but it still has to pass its way through the numerical system. It's like, what is 0 plus not a number? Well, that's equal to not a number. What is not a number plus not a number? Like the errors.
Still not a number.
Still not a number. The errors need to propagate in some way. And the Fortran textbook that I still have on my shelf from 1973 from Michigan Tech
yes.
Has I don't think it covers not a number because it's an introductory text, but a lot of the code that's in there, if you just cleaned it up a little bit and typed it into your favorite Fortran compiler, would work because the things have just not changed. And so people can build upon things that haven't changed. They can build scaffolding upon scaffolding upon scaffolding, and sort of at the very top of this stack, there's a shiny new language, and deeper down in the stack, there's less shiny languages, and very deep down, there's dusty decks. So sometimes a dusty deck doesn't work the first time on brand new hardware, and you need to have that kind of really smart, old, graybeard sort of person or young graybeard sort of person, or young person of any sort.
It's coming right in.
To make sure that, or gray hair, gray or no hair, who said, oh yeah, I remember back in 1980 whatever, when we were doing that before, that this obscure corner case happened, and like the elderly Fortran debugging code.
Yeah, you don't necessarily have to rewrite things that you can wrap. I suppose a side note also. Absolutely love the MTU /sticker. That / logo was definitely a big part of my past. I spent several very cold winters attending Michigan Tech in the
I grew up in the UP as well, up in Marquette. So not quite as much snow as Houghton got, but still plenty of snow. 270
inches per season on average. Sometimes in the north of 330.
Yeah. Just amazing. So get your skis out.
All right. So recent ARM news. So being that KubeCon and Cloud Native conference was this last week, which talks were you able to catch that you enjoyed or found some solid ARM insights from?
So one of the ones that was really great was Alex Ellis talking about the last 5 years of doing Kubernetes on Raspberry Pis. He's been at it. I mentioned my friend Dieter, who did some early Docker work on ARM that was at the DockerCon in I think 2016 or 2017. So there's been this steady progression of people trying to do things on computers that are way smaller than data center size computers. There are some, rightly so, who would say, oh, well, that's a toy. That's not a server. It's not standard. It's goofy. It's maybe useful for embedded systems, but mostly used for learning how to play Minecraft or something. Yeah, Turing complete programming languages for kids, no problem. But just the progression, the sort of really interesting thing about the talk and the field is that this progression of tiny underpowered computers in subsequent generations getting less tiny and less underpowered. The Pi 4 has you can get it with 8 gigabytes of memory. That's more memory than the 2014 MacBook Air on my desk. And it's stupidly inexpensive. You can put together a full system for $100 plus or minus all in, which is crazy talk, but that's where it is. So Alex went through this progression, and you should see the talk because he knows the detail because he's been building these clusters as things go, and porting his functions as a service software, the OpenFast, to it as we go. And Alex has been a friend of Packet and a friend of Equinix Metal for a bit, and we provide him some infrastructure and test machines and whatnot. But that was really good.
Yeah, I've seen some of his explorations. So a lot of the Pi things, and then sometimes with large server things. I think I ran back to one of his Twitter posts I was looking at earlier, and he fired up one of the Ampere machines in the house and trying to bring up different bits of his projects on those. And so on the Pi front, I think it's fantastic to have maybe if it's not necessarily production things, still something that's accessible to people, and the things that you learn and the lessons are still very applicable to
because who's going to let you take a server room full of computers and cut the power quickly, right? Or mess with the cables or something like that? Like, no one's going to let you do that. And if the single board computer has enough power, they typically have enough CPU to do something interesting. The challenge in the past has been, do they have enough memory? Because the footprint of the control plane for vanilla Kubernetes is a couple gigabytes easily. Sometimes with these, because the software is designed for data centers, and really never in that environment it grew up without the constraints of it has to fit in this small thing, because the constraint at planetary scale is not, does it fit? You've got those big data centers, it fits. The constraint at planetary scale is, does it continue to work? Or better yet, does it continue to work even in the face of partial failure? And those sorts of systems are perpetually in the state of partial failure. But the system works, it's just that the components are being swapped out, or lying to you, or failing to do something correctly, or someone pulled out a cable, or someone took a ditch witch through the fiber line, or whatever. So
yeah, those are I remember that having been the issue occasionally, is digging in places where things are unmarked. But yeah, I'd seen in addition to that talk, there were more of I think Alex recently also published a Pi 4 exploration, wiring up a NVMe drive to the.
Yeah, that was really cool.
I saw your face light up. And
so I did something similar previously. Jeff Geerling did a tutorial on a SSD drive to a Pi, and the problem with SD cards is that they're so cheap and so just reliable enough that you can count on them until you can't. And I've had a couple machines. Yes, that's what they are. The teeny tiny ones. So I've had a couple machines in the past have unexplainable failures due to SD card. It's less frequent than it maybe have been before, but it's still way more frequent than I would like. So I figure with the SSD, it feels more like it's permanent, as opposed to temporary and throwaway. And they're bigger, so you're less likely to lose them.
Yeah, we can certainly link the add that link in the show notes. It's something to go over. It may, as Black Friday comes up and it becomes rampant consumerism time, and especially since I won't be spending any money on travel this year, buying new toys for the home lab and experimenting there should be a thing. And so maybe a NVMe SSD to plug into some of the sundry Pis around the house. I have the normal ones. I've got some of the little bitty ones. I've got
the little bitty ones, sure.
Some of the ones that are encased in
something else.
In CNC aluminum.
I've got my I've got one plugged into a radio here. The blue tuner stick that you see on top of that is a software-defined radio. Yes, exactly. Very close.
A little ADSB.
It's actually not an ADSB one. It's just a general purpose one.
A general SDR. Okay, very cool.
I have it plugged into a Pi, and that Pi is running Luigi Cruz's Pi SDR software, which is a distribution for amateur radio, essentially.
Okay.
A bunch of tooling for spectrum analysis and communications. Mostly listening at this point. I think he's got some transmit tools, but they're mostly for listening. And you plug in your favorite SDR and plug in your favorite antenna and start listening to the net.
Yeah, we're gonna have to talk amateur radio and software-defined radio in a future one.
Yes,
I know. I don't have to assume, but that's where your Twitter name comes from. I think that's visible to everybody on there. If you're,
it's also way shorter than my last name, which is kind of hard to spell.
But yeah, I very much like having a lot of it from cost and accessibility purposes, the Raspberry Pis around the place, mostly because I feel I can take them in a fair fight. We're worried about the rise of the machines and Skynet and all of that, right? And so I figure you've heard the old brain teaser, right? What would you rather fight? One horse-sized duck or 25 duck-sized horses? And I feel like these are the computing duck-sized horse. Like it's not a ton of angry duck meat in the with the disposition scaled up to match. And so I think I could fight them.
I think you could. Well, they're fun. They're fun in large part in the ways sometimes that servers are not, because they can easily be said single-purpose computer, right? What is this thing going to do? Well, it's going to listen to the radio. Okay, what's the next thing going to do? Oh, it's going to drive a screen and keyboard. Oh, what's the next thing going to do? Oh, it's going to keep track of ambient temperatures. You don't have to timeshare. You don't have to multitask. You don't have to Kubernetes. Yeah, you could if you
But
wanted
you can.
to. You don't have to. You can, but you don't have to. So just because even the older ones have enough power to do real genuine computing. Um, the fact that something is obsolete doesn't necessarily stop you from putting it to good use, right? So so the KubeCon was really fun. I spent a lot of time in the hallway track. The hallway track this year used, what did they use? They used
There were
Zoom.
multiple hallway tracks.
There were multiple. It's a big convention. There's a lot of hallways. There was a Zoom going on. It really felt like a conference, like in ways that other conferences that I've been to didn't feel like I was there. It felt like it did feel still remote, but it felt like a lot of people were remote at the same time had their attention focused on the same spot. It's like, you're not bathing in the sunshine, but there's a little magnifying glass pinpointing some sunshine on you, and a lot of people are pinpointing the sunshine on the same spot, so it feels like it gets heated up.
If you could sort of Voltron together the Twitter and the talks live streaming and the CNCFs set up a bunch of channels in the Slack and the Zooms that would pop up. And there was also, was it Rambler?
Rambly. Rambly was fun. Oh God, Rambly was fun.
Explain a bit what Rambly is.
If I can. So Rambly is at its core a peer-to-peer voice chat system. There's no central server multiplexing your voice. It all goes from your browser to other people's browsers directly. So you're talking, someone else is talking, a third person is talking, you can hear everyone. You want to wear headphones for Rambly because it doesn't have echo cancellation, because it doesn't know what other sounds are being made, because it can't really tell because everyone is doing things at the same time. So you can do push to talk, where you start, you press the space bar to talk and let go when you're done, or you can leave a hot mic open and embarrass yourself by talking about things that you shouldn't talk about, right? So fine. Or you can forget that you.
But the front end
is like magic. So it's like a 90s video game. You've got a little character you can pick. It's got a little caption underneath it with your name on it. You up, down, left, right to move your little character through this field that's got boulders in it and tents and an ice cream stand and
a giant movie screen, so you can
movie screen.
So you can watch the keynotes with other folks and sort of feel in the same room that way. I think that the voice chat is also proximity based somewhat too. Yeah.
Yeah, the voice chat's proximity based. So if you're a little character and someone else's little character right next to each other, or if you're up close to the screen, it's noisy or loud or has full volume, and then as you back away, it gets quieter until if you get too far away, you can't hear it at all. And I was in the hallway track talking to a fellow whose name I blank out on right now. I didn't write it down. I should have. Who was blind. And he said, oh, this isn't too bad. It's pretty accessible from a screen reader perspective. And it feels like I'm in a room, because as people go past you, there's no you're not moving fast enough to get a Doppler shift, okay? But you are moving fast enough to be able to tell that the sound is coming from one ear.
It's stereo.
Which is really great.
It's proximity
stereo.
Audio is stereo.
It's stereo.
Okay.
Yeah.
I didn't pick up on that when I was using it.
Yeah. So you can tell if you're listening carefully, you can tell if someone's to your left or your right, and how far away they are, which is almost enough to give you this illusion of 3D space, because it is effectively 3D audio space or 2D audio space. So Rambly was fun. It turns out one of the secret things in the Rambly space is a link to a Discord server. So if you want to figure out what they're actually planning and what they're actually doing and how they're actually thinking, there's a developer hidden spot there, and I just found that today. So I'm going to give it a try. And as far as I know, there's no custom scenes yet, but there's no reason that your favorite movie theater or campground or whatever couldn't be represented as a background on Rambly. So I'm hopeful that the developers are having as much fun with it as I am and continue to do it.
Yeah, maybe we get to have a holiday happy hour together inside Rambly at some point.
Inside Rambly somewhere. Yeah.
There should have been you could tip folks off to sessions coming up. What else went on at the conference? There was talks on Firecracker. I saw notes that might be a.
I didn't see it myself. I'm going to try to catch it over break. But there was a talks on Firecracker. What was the other one? I spent so much time in the hallway track. The show floor was on Slack and also in people's private Zoom things. So I found myself on Slack going back and forth between channels, like picking someone up and dragging them into the ARM channel and saying, you just announced this new cool software. Like the Circle CI folks just announced that they're doing Circle CI runners on ARM so that you can bring your own hardware. I think you could even bring a Raspberry Pi, but we're looking at it for bringing server class hardware.
Sure.
And then have your CI jobs execute on the node that you brought. And so when I saw the press release, I found their channel, right? They created a bunch of new channels for sponsors and asked the question, found someone who would answer it, then mentioned them in the ARM channel. Hey, they're doing this new thing. Here's this person who knows more. And he very gracefully said, well, I don't really know very much more, but I know how to find the person who knows more. And it was very much, if you play it right, it feels like you're walking from booth to booth in a trade show, right? You want to find someone, you want to drag them around with you. You can't just sit there passively waiting for people to show up and ask you questions because they might not ask you questions. You have to sort of circle around. And it reminded me in that way of some of the Open Source Summit events that I've been to that had a big show floor that I spent a lot of time standing up in a booth next to and handing out business cards and handing out stickers.
Stickers. Maybe we'll get T-shirts or custom Rambly avatars for the next time. We'll find a little wonderful Fortress logo or something like that. A little Metalbot helmet.
Metalbot helmet. We got. I should be wearing my Fortress logo right now. My little metal pin. If I could do this. Should have done that before. Anyway, the KubeCon was fun in ways that, I don't think it was universally loved by people who were vendors. They had some struggles with their AV. Some of the keynotes were hard to follow because the video was really choppy from their conference streaming vendor. I don't remember the name of the conference streaming vendor, but not perfect, but I do think that it was transformational in some way that there was enough of a sense of community there, and there were people participating, and there was socializing as well as talks, and you could ignore most of the talks and still feel like you had gone to an event. And in Rambly, there's an ice cream stand, so we had ice cream. You line up, your little avatar lines up in line waiting for the ice cream, and someone stands behind the booth, asks you what you want, and you tell them what you want, and They give you ice cream and then you move aside and then everyone shuffles up the thing. It's a video game. It's the metaverse. It's the metaverse, Jerry. We're all
got to make him got to bring it into the real world and drop some of that freeze dried astronaut ice cream into the
exactly.
Into the
you just need to send someone a conference kit that includes all the things that they will discover during the course of the conference, right?
Yeah. What other ARM things came up?
What other ARM things came up?
Was there looks like Knative maybe?
Knative, yeah. So Knative is another serverless platform. They did an announcement that they had finished their ARM port. That's great because Knative is a dependency for a number of other projects. So sort of tackling even if you haven't heard of Knative, and I don't know the Knative ecosystem all that well, but it's the sort of thing, it's like, even if you haven't heard of this, it might be really important because something else might be building on top of it without you knowing about it.
OpenEBS?
OpenEBS, yeah. Which is really great. Murat and the crew at Maya Data have been working on this. There was a lot of work to do to port this because not only was the software, it's a storage system, right? That's a non-trivial thing to test. But also getting the whole container build infrastructure right so that you can build ARM and x86 versions of all the containers you want. If you have dependencies, they have to do that too, and so on down the stack. So getting that all working. And then OpenEBS itself, like I say, just getting enough infrastructure in place so that you could test it. And they've been working this for a couple years now to get it to the point where they're happy enough with it and confident enough with it to announce it to be there. So you've got the show notes that I sent you. What else did I say?
UEFI?
Yeah, so UEFI is one of these essential things that hardware people know about that software people mostly have been insulated from. It's part of the boot environment for servers. And so if you look at a Raspberry Pi, typically in the past, it would boot in a way that would be strange to a server person. And so there's a couple UEFI projects at, I don't remember which conference they announced it at, but Andre Workington did a UEFI for the Pi 4 so that you can boot standard operating systems, standard ARM64 versions of operating systems straight from that. And then NVIDIA announced that they have a UEFI for the Jetson Xavier, yeah. And I think there's a couple of Xaviers, one of those things, I think that's their high-end one. And basically taking a system that was originally marketed as an embedded Linux system, where people are usually pretty tolerant of goofy configurations, and setting it up so that you could treat it like a standard server and run Tinkerbell against it or anything else like that. Speaking of Tinkerbell, as you may know, as the future might know but might not know, Tinkerbell is a environment for booting servers. It's got a Pixie client, it's got boot DHCP in it, other sorts of things necessary in that brief moment between the time you power on and the time you get a login prompt, which, again, a lot of the people in the metal world really live in that time span. And a lot of people in, say, the JavaScript world are completely oblivious to it. But Tinkerbell got accepted by the CNCF as a sandbox project. And we are all very happy about that because the CNCF is awesome. And they do a lot of good work. And it's always good to have project support from a foundation because there are people who like They know how to run a project. They've got checklists for things that have worked before, and they keep their checklists up to date. And you know that if you've made it through the gauntlet of getting okayed as a sandbox project, that a whole bunch of stuff opens up for that. The other thing, and this might be burying the lead, but the CNCF announced together with Equinix that we're now supporting the Community Infrastructure Lab there, which has x86 and ARM servers in it, to the tune of $1 million a year. Like it's always nice when you work on a project for a couple of years and then suddenly a press release goes out and a couple of days later the CEO says he's proud and excited to be that we're doing this. It's like, all right, that was a good year. It's a good way to end up the year. So the community.
Excited to see how the lab is used, and that's a good way to keep up on up and coming projects.
Yeah, so we've had a couple projects like the Community Infrastructure Lab is in some way the place where sandbox projects that aren't sandbox projects yet get their start. They're not yet in. Some of them are further along, right? But people who need some gear, who maybe don't have an organization yet, who maybe don't have foundation funding, or they've spun something out from a company, but it's really kind of not finished yet, and it's not commercial. There's no way that you could justify paying full-on commercial rates for the infrastructure, yet you need it because you're doing cloud native, and cloud native, is designed at planetary scale. So you have to be able to have access to some of that hardware, and maybe temporarily, at least, maybe a lot of the hardware. So we're really happy about that. The support that we provide. I don't have a list in my head as much as I have it for the ARM side of the world because I haven't been doing it quite as much.
Perfectly all right. Luckily, when folks find this in the future, down here in the description will be a link to some of those projects and the ways to reach out and get connected to those resources.
All you have to do is ask. Ask for help. Ask for resources. You might get a no if it's not exactly in tune with things, but often we can vector you off to some other effort that's sort of more in tune with the proposal. The Works on ARM project uses GitHub for proposals. The CNCF Community Infrastructure Lab uses GitHub for proposals. So all you have to do is open up an issue. And you can read through, in each case, 100+ previous issues that have been looked at and whatnot. So if you want to do some reading before you do some writing, you can do that. What else is exciting? On the resources for open source software front, we've been working with FossHost, which is an open source hosting project based in the UK with a global network. Equinix Metal supports that, but a bunch of other vendors support that as well, including DigitalOcean. I hope it's DigitalOcean that's on that. And they provide infrastructure for virtual machines for people. So if you don't need a whole bare metal machine, right? You don't need 128 gigs of memory. You need 8 gigs of memory, or 4 gigs of memory, or 2 gigs of memory. You can get a VM that's right sized for your project, and they'll help you run it. They're running a global content delivery network on these donated systems. It's all donated. So if you're doing software distribution and you're getting eaten up by egress charges, you have an option there. And it's just it's a lot of fun. We're providing them with some hardware out of our Dallas data center. We had the really unfortunate incident, almost unfortunate incident of having some hardware go bad and having to do some disaster recovery.
What means go bad? Is that the rise of the machines that we were talking about earlier, or is that grows a goatee and starts doing crimes, or what's the?
No, it was. So we're still investigating exactly what happened, but the problem manifested itself as drives in a big ZFS pool going offline. And ZFS, thank goodness, is really resilient to that. But there was a fear that the more reads you did, the more drives would drop off this net. So I don't know ZFS as well as I might, like zpool 2 or something like that, where there's like, approximately 2x redundancy for things. But we did a maintenance call with them and got them onto appreciably newer, like state-of-the-art hardware, and they're up and running and ready to have at it again. And their backups have been tested; they work. It's good to know that. It's good to know that. So when you get systems, you get failures. I mean, at scale, things go wrong. And it was a case where the two of us on the Equinix Metal side just hung out in their IRC channel for a while until it was all better, answering questions and whatnot. So, and then you've been through that, and then it's not going to happen again. So you're happy again. So.
Perfect. If folks want to track down more information on the on Works on ARM or follow along with those developer communities, where are great places to hang out?
In the ARM world, the single best place to hang out these days is a Discord server, the ARM developer community Discord server. For reasons which I really appreciate, they decided not to go with Slack for their central community. Discord is traditionally more of a system that appeals to people from the gaming world rather than from the business world. But they've been really effective, have lots of channels, they're well curated. There's people on there all the time. So that's a good thing, and you'll in the show notes of that down here there will be details. In addition, I host a weekly Works on ARM call. It's not recorded, it's not broadcast, so people are free to speak freely. The only rule is you have to say the word ARM at least once in the course of your discussion, and then we typically talk about ARM stuff, but RISC-V sometimes shows up and other sorts of things. And that's Thursdays at 4 Eastern, 3 Central, 2 Mountain Time, and 1 Pacific Time on a Slack channel, on a Zoom call.
Okay.
And there's a Discord channel and a Slack channel in the Equinix community Slack, and a few other parallel places. There's a Works on ARM Twitter, which we're in the midst of transitioning social maintenance of from Equinix Metal to ARM, so they're going to run that directly, and I can't wait to see what they come up with for that. It's a pretty well together, well knit community, the ARM world. A lot of folks have been to a conference called Linaro Connect. Linaro is a contract engineering firm that does a whole lot of work for ARM, and they've been at it since the very, very, very beginning. Back when the only way to run was in emulation, and have seen a number of generations of hardware and a number of generations of software. Linaro Connect was in person in a bunch of cities. I was in Bangkok for it. I was in San Francisco for it. Now, these days, it's virtual, and so a lot more people get a chance to participate because they don't have to fly quite so much halfway around the world. That's coming up. I don't have the dates. I think it's March, but we'll have the details below.
Of course.
Here. I know how to do this now. And Leonardo Connect should be, especially with the influx of new people in the ARM world from Apple. I'm expecting it to be extraordinarily interesting this year, or next year, actually.
Yeah, we've just got another carry the 240 days or so of 2020. We're going to make it.
Something like that. We're going to make it. Totally. And then the other event coming up in February of next year is FOSDEM, which is traditionally in Brussels and is typically on a European time zone. So they're going to do that virtual this year for reasons. And I think their tagline is 8,000 developers, 600 talks, all squeezed in one weekend, which is crazy talk, but there you go. That's a lot. One of the fun things about FOSDEM is that they have a fringe festival where people who are not at FOSDEM or didn't plan ahead enough in time or aren't ready to do it or whatever can schedule events basically on the Friday previous or the Monday afterwards and do the pre-show event or the post-show event. And I'm really thinking that we'll do an ARM-themed pre or post event on a weekday, so I can call it work. So I'm looking forward to that too. That's in February.
Excellent. We'll keep up to date on those, and available as show notes. I think as we approach tail end of the hour here, I think the only thing that we've missed was looking at what's more things that are available Apple Silicon wise, and so Google Chrome, yes, Edge soon. Yeah,
and Homebrew, which is the big package collection for the Mac. There's one of the issues in the Homebrew repo has a very, very detailed accounting of all the stuff that works, all the stuff that doesn't, and if it doesn't work, why it doesn't work, what it depends on. And so walking that dependency tree to figure out like exactly where you need to go is really important to figure out what happens next. You know, like, oh, we need Fortran, right? Because we need Fortran to get R. Or we need Haskell so we can run Pandoc. You know, like important stuff, like things you might not know exactly. The nice thing is that Rosetta makes some of that go away because you should be able to basically work your way around by emulation. But although emulation is lovely, there's nothing that beats the real thing.
Yeah, there was a reason the switchover was made.
Yep. They're supposed to be really fast. I'm looking forward to it.
Anything else before we send this one out?
I think we're good. We covered events, we covered announcements, we covered talks, we covered a bunch of software, a bunch of hardware. I said the word RISC-V at least once, so that's just acknowledging that world. That's a whole other show. I think that that'll take us close to the top of the hour.
Perfect. I'd like to thank you for joining me. I'd like to wish all of our metalheads out there a very happy holiday harvest time. And I think, what commitments am I going to make? I think, Black Friday sales, tracking down a NVMe drive and shell to work through that LXLS post on and share results, or at least have the happy home lab experience. We will be back the Monday following, and so just 6 days from now, and we'll see y'all again then.
All right.
Bye for now.
Bye.